the second part of Trig Day talking about inverse trig functions and not really spending too much time on them, just to note how I think you should think about them. So if you're given sine, and I should write it over here. If you're given inverse sine or arc sine, those mean the same thing. If you're given arc sine of root 2 over 2, you're trying to figure out what that is. The what that is, I'm going to represent that with an x. Okay? So if I have this expression, there's another way to write this expression. And if I take the sine of both sides, I could rewrite this expression in this way. Sine, well, I should give you order. Root 2 over 2 is equal to the sine of x. So what this expression initially is asking you, is it's saying, what angle has a sine value of square root of 2 over 2? Right? So this question originally, on its own, is find an angle whose sine is root 2 over 2. If you think about it like that, or if you rewrite it like this will help you determine the value without using your calculator. Okay? So so how would you do that, right? So now you have this expression, and the question is, well, how do you figure out what the angle is just looking at this? Well, they're not going to give you a problem to do by hand without your calculator that is an angle of 63 degrees or something like that, right? It's going to be one of the common angles, 0, 30, 60, 45, 90, and so on, intervals of those. So if we know that, then we can think, is it a 0, 90, 180, 240, 360, is it one of those that would land on the axes of the unit circle? Or is it one that uses the special right triangles? Well, our special right triangles are 30, 60, 90, and 45, 45, 90. If, again, convert these all to radians, right? If I have a square root of 2, that tips me off that it's going to be the 45, 45, 90 triangle with pi over 4, pi over 4, pi over 2 triangle. So that looks like this. Pi over 4, pi over 4, 1, 1, root 2. And I'm trying to figure out what the angle is that yields a sine value of root 2 over 2. Root 2 over 2 has been rationalized. Root 2 over 2, so this does take a little bit of thinking here, was originally 1 over root 2. And then some mathematicians got a little antsy about that square root in the denominator and changed it to square root of 2 over 2. Isn't that so much better? Anyway, the point is we're looking for the angle whose sine, whose opposite over hypotenuse, is 1 over root 2. So here's 1, here's root 2, there's our hypotenuse. This must be opposite of the angle then must be pi over 4. You probably all arrived at that conclusion earlier than that, but that's the thought process if it wasn't the pi over 4, pi over 4, 9, pi over 2 triangle, if it was the 30, 60, 90 triangle. Okay, so that tells me then that inverse sine of root 2 over 2 is equal to pi over 4. Okay? Obviously, a calculator makes this a little bit easier, but you can figure it out without using a calculator if you remember that an inverse sine or an inverse trig question is asking you the angle whose value is the trig ratio. Okay? So, I'm going to pause for a second here and we'll look at the graphs of sine and cosine, and that'll round out our crash course in trigonometry. So the last thing I want to talk about is graphs of sine and cosine. It's a good idea to have one cycle at least of sine and cosine kind of also memorized, or at least be able to build them before you take the AP test. So let's look at, we'll start with sine. And these curves, the squiggly curves, as they're technically referred to, they come from the unit circle as well, right? So we talked already about how sine of 0 is 0. So if you were trying to map angle versus sine value, so theta on the x-axis, so theta here, and then sine of theta on the y, what you would do is you would just map all of the heights corresponding to the angle. So at angle 0, you have a value of 0, a sine value of 0. At pi over 2, you have a sine value of 1, because the height there is 1. So at pi over 2, we have a height of 1 unit. And that will continue. And notice that that has to be a maximum of sine because the height of the point never goes above 1. Right now it starts coming back down. And so it's going to start coming back down until you get to pi, where it hits 0. And then at 3 pi over 2, you'll have a value of -1. So you'll have a value of -1 here, which you can put on the y-axis. All right, and then at 2 pi, you will have a value of 0. So at 2 pi here, you're back to 0. And that's one complete cycle of the sine wave, because then it just starts over, right? So you can see that pretty clearly from the unit circle. That's where the sine wave comes from. Cosine, we approach it the same way, except cosine of 0 is going to be 1, right? So cosine is the horizontal length, or the run, maybe you think of it like that, at 0. Well, if it's the unit circle, this distance is 1 unit. So it's going to start off here at 1, and then immediately start going less than 1, right? Because you can think about the horizontal distance changing as the point moves around the unit circle. It will hit 0 at pi over 2. It will hit -1 here at pi. And then it will hit 0 at 3 pi over 2. And at 2 pi, you'll get another maximum. Please forgive my poor drawing here. You get another maximum of 1. Okay, so knowing these values for the graphs and how being able to generate the graphs from the unit circle is really useful. I also have students that like to memorize these, and it helps them get back to the unit circle. So however you want to do that, it doesn't matter. I just want to give you some systems for thinking about them. But these graphs are a good thing to memorize. It's also not hard to figure out from the unit circle, but you want to have a good idea of the behavior of tangent as well. So you want to kind of be able to know where the asymptotes are, or be able to figure it out from the unit circle where that the asymptotes would be at pi over 2, 3 pi over 2, and every pi after that. So that's why the period of sine and cosine is 2 pi, because of the unit circle. And then I will say one thing about the period of tangent. The period of tangent is pi, and the reason is that if you think about it in terms of the slope, tangent value being the slope, well, suppose here the slope is, I don't know, suppose it's 1, suppose that's 45 degrees or pi over 4 perfectly, right? The slope will hit the slope will hit 1 again as you spin around the unit circle here, right? And so then you think, well, what is the difference between, or what is the angle between when it was 1 here and then when it was 1, slope of 1 right here? That angle is 180 degrees, or pi radian. Okay, so that's why tangent has a period of pi. If there's something that you think I missed in the trig crash course here that you think should be included, let me know. But otherwise, those are some of the important things you want to have ready to go for the AP Calc test.